Hey guys, I hope you had a great fall break. Good news, only a 4-day week. That's exciting. We are going to have our first unit test for the second 6 weeks this week. So today, Tuesday, we're covering direct variation, and that's our last topic. So we talked about functions, and then I'm putting in direct variation because it kind of has a little bit to do with it, and it's an introduction into slope, which is what we're going to talk about next. So we're going to cover that today. Wednesday, we're reviewing for your test. There will be a review. I will make a video of the review as well so you can check yourself. And then we'll work on that in class. And then Thursday will be your test over functions and direct variation. And then Friday, we will be moving on to slope and all the fun stuff. So direct variation. Direct variation is a special type of linear relationship. Sorry, y'all, that's an R. Relationship where y divided by x is always the same. So direct variation, a special type of linear relationship where y divided by x is always the same. So the equation for this is y equals kx. And k in this equation this is called the constant of variation. And k is just where you get the y divided by x. So k, your constant of variation, is y divided by x. So when we're looking at the equation, k is always, always, always right next to your x. He's always beside it. So whatever number, fraction, decimal, it could be anything, whatever is right beside touching your x is your k. I'll talk about this in 7th grade as well, so this is not brand new. You've heard of this before. So if I look at these, it's asking for what is the constant of variation in the problems below. So remember, it is y equals kx. It's looking for the constant of variation, which is my k, the number right next to my x. Well, 4 is the number right next to my x. So the k, or constant of variation, would be 4 for this problem. Super simple, right? Not bad. We'll look at number next. Again, y equals kx is the equation. I'm looking for x, so looking for k, whatever number is next to my x, which would be 1/2. So in this equation, my k, my constant of variation, is 1/2. Again, constant of variation is your k. It's y divided by x. We'll get to that in just a second. And it's whatever's next to your x. So let's try this last one here. I want you to try it. Okay, so you should have, had y equals kx. Again, we're looking for k, whatever number's next to the x. So in this case, k should be 2. So hopefully you feel pretty good so far. Just identifying your k in your equations. It's whatever's hugging your x, whatever's next to it. Important, direct variation is the same as slope. And again, we have not talked about slope in detail yet. You've talked about it last year. We'll get into that in the next unit, but this is kind of an introduction. It's the same as slope. So y equals mx plus b. Again, we're going to get into this later. M is your slope. M is your slope. B is your y-intercept. Where it crosses the y-axis on your graph. And again, please don't feel like this is overwhelming or I've not learned this or whatever. We will go into so much depth on this. The first half of algebra is all about linear equations, but just how this relates. So if you look at this equation, y equals mx plus b, and you looked at our direct variation equation, y equals kx, y equals kx, well, you noticed m and k are in the same spot. They're right next to x. So therefore, direct variation is the same as slope, because m is the slope. And then if you notice, there's no b. There's a b here, but there's nothing over here. So the b, again, it tells us where it crosses on our y-axis. So if I had a coordinate plane here and I have my x-axis and my y-axis, if that were plus 2, here's my y-axis, I would start at 2. And again, we're going more into detail this later. I'm just kind of showing you how direct variation relates. There's nothing there. So if there's nothing there, what could I add to make this not change the equation? Well, the only thing I could add would be plus 0. So therefore, my y-intercept every single time is 0. Because there's nothing here, and the only thing I could add would be that plus 0 to make it not change the equation. So for direct variation, so far we've learned k is the guy right next to the x. It's also the same as our slope. And our y-intercept for it all is always going to be 0, which means it's always going through this spot right here. It's always going through the origin every single time, because that point's 0, 0 every single time. So here is what I want you to do. Anytime you see the words direct variation, or if you see the words varies directly with, you're going to always, always, always replace it with divided by. Oops, divided by. Every single time you see those keywords, cross it out, scratch it out, and write divided by instead. Because if we look at number 4, it's going to make a whole lot more sense if we write divided by than varies directly with or direct variation or all those fancy math words. If we just write divided by, it's going to make a whole lot more sense for us instead of being all fancy. Because you know us math people, we like to be fancy. So if y varies directly with, oh my gosh, keyword, varies directly with, I'm crossing it out. I don't want to see it, and what am I replacing it with? Divided by. So if y, instead of varies directly with, I've got if y divided by x, and y is 20 when x is 4, what is the constant of variation? What is the k? So it says y divided by x, right? That's what this statement says right here. Y divided by x. That's my k, equals y divided by x. But hey, it told me that y is 20. So everywhere I see a y over here, I'm going to put 20. And then it also told me x is 4. So everywhere I see an x, I'm going to replace it with 4. Well, now I've got 20 divided by 4, which simplifies to 5. So my k, or my constant of variation, is 5. And again, all I did was cross out varies directly with, and it told me exactly what to do. I take y, and I divide it by x. So let's look at number next. I've got if y varies directly with, yuck. Cross it out. I'm going to write divided by. So if y divided by x, that's our k, right? Y divided by x. When y is 7, so where I see a y, I'm putting 7. And x is 35. So where I see an x, I'm putting 35, right? Well, now option 1, you can simplify if you can see it and you're like, hey, top and bottom both divide by 7, so I'll have 1 divided by 5. Perfect. Or if you need to, you're not great at simplifying fractions, that's fine. You can go to Desmos and you can plug in 7 divided by 35. It'll give you this decimal point 2, and then you hit the fancy fraction button over here on the left, and it will simplify the fraction for you. So it tells you 7/35 is actually equal to 1/5, and it'll simplify it for you. So when we're doing our solve for y test and all of that, use this if you're not good at simplifying. Please simplify. So this is actually equal to 1/5. My K is 1/5. So again, I'm just plugging in. It tells me exactly what to do, and I am just plugging in. Okay, let's try this one. This one's got a little bit more to it, but I think y'all got it. So if y varies directly with, ew, gross, cross it out. And we write divided by. So again, I've got y divided by x. And y is 25 when x is 15. What is it when what is x when y is 30? So I have my x, so I have my bottom number. I don't have my bottom number, but I have that y is 30. So now I've got a proportion. And if you remember how to do proportions, you cross multiply. So I'm going to cross multiply 15 times 30. And 15 times 30, I get 450 equals x times 25, which is just 25x. Then I solve for x to get x by itself. So I'm going to divide by 25, divided by 25. 25 divided by 25 goes away. I'm left with x equals 450 divided by 25, which is 18. And again, if you need Desmos, you can use Desmos to do all the calculations. So when y is 30, x will be 18. So when it gives you 3 different numbers, you're going to be doing this proportion. When it just gives you 2 numbers, you're just going to be doing y divided by x. Okay. Let's look at number next. Let's look at 7 and see what's happening. The number of servings of soup varies directly with, yucky, divided by. So now it says the number of servings of soup divided by the number of cups. So I've got servings divided by the number of cups. So if I look at A, it tells me I've got three cups. 3 cups serves 9 people. So servings is 9. So I'm just plugging in what I have. So I'm plugging in servings divided by the number of cups. And 9 divided by 3 is 3. So the constant of variation, my K, is 3. Right? So now I have, if I had to write an equation, remember my direct variation equation is y equals kx, where k is what? Constant of variation. Well, now I have my constant of variation. I said it was 3, so now if I were to write an equation, I can plug in what I just found out. So now instead of y equals kx, I have y equals 3x. And it wants to know from 8 cups. 8 cups. So if I'm serving x people, or x cups, which is 8, now I'm just going to plug in 8 if we're seeing x in this equation. So I've got y equals 3 times 8. So y equals 24. So if I have 8 cups, then 24 can be served. C says, how many cups would it take to serve 39 people? How many cups would it take to serve 39 people? So again, I have my servings and cups. Need a little bit more room here. Can I write it out to the side here? let's see. Didn't give me a whole lot of room. Servings and cups. We're going to have to do a proportion here. So if I use this old one from up here, I know 9 servings for 3 cups. Well, I want to know 39. So I have 39 on top, and I want to know the x. So again, we're going to cross multiply. 9 times x, which is 9x, equals 3 times 39. 3 times 39. And again, you can go to Desmos. 3 times 39. Oops. Here we go. Nope. Is 117. So then I have 117. I've got to divide both sides by 9. So I have x equals, computer's about to die, perfect. I have 117 divided by 9, which is 13. 13. So it would take 13 cups to serve 39 people. Sorry, that was a little cramped, y'all. Hopefully you can read that. My bad. Okay, this one says, the table below represents the amount of money Dan earns at his job as a function of the number of hours worked. How much would he make after working 12 hours? So, again, it's y over x. So hours is my x. If I work x amount of hours, I get out this much, y. So x is my input, y is my output, right? So if I work 2 hours, I get $31. Yes. So if I'm trying to find k, which is y over x, yes. I know if I use this, I'm just going to plug in 31 over 2 equals, well, I want to know 12 hours. So I need to have 12, and I need to find up here. And I guess that would be y, not x, because it's on top. We'll make it a y. It'll still work out the same way. So then I cross multiply. I've got 2y equals 31 times 12. Again, you can plug it into Desmos. I got 372. And then I divide both sides by 2, so I can get y by itself. And so y equals 186. So if I work 12 hours, I should get $186. Yes, no, maybe so. Sweet. I think, oh no, we got 3 more. The graph below represents the distance a delivery truck travels as a function of the time spent on the road. How far will it travel after 7 hours? How far is it traveling per hour? Okay. So first, let's figure out where these points are. I've got over 1, up 15. This one's over 2, 30. And this one's over 3. And then are we going up by 20, 25, 30, 45. So there are our points, right? So again, if I'm trying to find my equation is y equals kx, where k is my constant of variation, or y divided by x. So if I look at this first point here, points are given in x, comma, y. So if I divide my y by my x, I'm going to have 15 divided by 1, which is 15. So if I were to rewrite this equation using my new k, I would have y equals, instead of k, it's 15. That's what I solved for, x. And it wants to know how far will it travel in 7 hours. So I need to plug in a 7 for my x. So y equals 15 times 7. Again, plug it into Desmos, and you get 105. And how far is it traveling per hour? That's kind of what we did here. We had hours are down here at the bottom, the x, and then the y-axis is how far it's gone. So after 1, here's our hours, here's our distance. So after 1 hour, we've gone 15 miles. And again, that's what that thing's saying. So it says we're going 15 miles per hour is the second question it's asking. Okay. And let's look at number 10. One more after this. Number 10 says, a group of people are tubing down a river at an average speed of 2 miles per hour. Write a direct variation equation that gives the number of miles y that the people will float in x hours. Complete the table, graph the equation, and determine distance traveled in 2.5 hours. Right? So if I have hours and miles, and again, hours is my x. If I plug in x, that's my input, it'll tell me how many miles we've gone. So in 1 hour, I've gone 2, because it says 2 miles per hour. 1 hour, I've gone 2, right? But what if I go 2 hours? Well, I got to add another 2 miles to it. So now I have 2 more, which is 4. If I go 3, I'm adding another 2. 4, I'm adding another 2. And then I'm adding another 2 for 5. So then if I graph down here, x again, this is my hours. And then over here on this side would be my miles. Oh my gosh, y'all. Miles. 0, 1, 2, 3, 5, 6, 7, 8, 9. Then let's count by twos, since that's what we're doing. 4, 6, 8, 10, 12. So if I go 1 hour, I've gone 2 miles. 2 hours, I've gone 4. 3 is 6, 4 is 8, 5 is 10. Right? And it asked, complete a table, graph, and the equation. So now I've done the table, I've done the graph, now I've got to do my equation. So again, equation is y equals kx. I have to figure out what k is. K is y divided by x. So if I look here at my table, I'm going to use, let's use this guy, right? So I'm going to do 2 divided by 1, which is 2. So my equation is y equals 2x. Isn't that what I did for here? If I was trying to find y, I plugged in 1 and got 2. If I plugged in 2 times 2, I got 4. 3 times 2, I got 6. Kind of what I was doing. And it wants to know the distance, determine the distance traveled in 2.5 hours. So now I need to plug in 2x, but now I'm plugging in 2.5. So y equals 5 miles. So in 2.5 hours, we've traveled 5 miles. So there's everything. There's the equation. Here's the table, graph, and then the how much in 2.5. So just remembering that equation, y equals kx, and then really making sure we remember it's y divided by x for our k. Okay, number last. The cost of 5 pounds of apples is $12.45. What would the cost be for 12 pounds of apples if the cost varies directly with, yucky, we replace it with divided by the number of apples purchased. So we have cost divided by the number. Cost divided by number of apples, right? Well, up here we had the cost was $12.45 for 5 pounds. And we want to know if I get 12 pounds, what will the cost be? So again, I'm going to cross multiply. And I get 5y equals 12 times 12.45. Plug it into Desmos. 12 times 12.45 is 149.4. And then I have to divide that by 5. 149.4 divided